So this is the side of our house, and they're putting, like 2x4 bracings on this house to support that wall. Does that make sense? Um, so they put this bracing here, which makes a 45-degree angle with the wall, and then they put a second brace, a longer one, that makes a 30-degree angle. Okay. The key to this question is that these two things are sharing the same kind of endpoint down here on the ground. Okay. If we don't do that, this question is not able to be solved. Okay. Um, but you guys have seen like in construction, if you ever watch somebody like building like a barn or something like that from the ground up, they will put posts in the ground and then support them with these side braces, right? Okay, and a lot of times they will put those side braces at the same spot. All right, so what's going on here? Well, if we look at this, the initial question says find the length of the longer brace. So the longer brace is that red segment. They want you to find the length of that, knowing the length of the smaller one. And the only way we can do that is to look at the fact that that longer brace is part of that right triangle. And that right triangle is a 30, 60, 90 triangle, right? But if I look at all of the parts of that 30, 60, 90 triangle, that side there and that side there, I don't know anything about them. Okay? It's not until I look at this triangle here that you're able to determine a part of the 30, 60, 90 triangle. Because in that darker triangle, it's 45, 45, 90. So don't you know in a 45, 45, 90 that this side here is in, and that side is in, and this is n radical 2, right? So that 20 in my n radical 2 should match up and give me my equation, right? So I'm going to say n radical 2 is equal to 20. I'm going to divide by radical 2. Now, just because I've done enough of these, I know it's probably a good idea to rationalize this because I see that 20 and eventually this 2 are going to be a common factor or have a common factor. So we get 10 radical 2. Does that make sense, everybody? That is then that distance there, which is that one. And it's also that distance there, which is that one. Now, why do I like that bottom one? Would you guys agree that that bottom distance right there is a component to the overall 30, 60, 90 triangle? That's a side length of your 30, 60, 90. So if I draw my 30, 60, 90, I just think it's a really good idea just to eliminate some clutter, to redraw these things. That's 30. This would have been 60. This is the red brace that we're trying to find the length of. And we now know that like up to there is 10 radical 2. But we also know that that entire thing right there is 10 radical 2. Does that make sense, everybody? And in a 30, 60, 90 triangle, remember the hypotenuse is always 2n. Across from 60 is always n radical 3. And across from 30 is always your n, right? So for my 30, 60, 90 triangle, I now know that this bottom side here is 10 radical 2. And does that allow me to find out what 2 times that would be? What would 2 times 10 radical 2 be? It'd be 20 radical 2, right? Okay. So that's nice, and that's what they're going to ask here for our question. Now it says find round to the nearest tenth as needed. So what I'm going to ask you guys to start doing. It's a program online. It's a free calculator. It's called Desmos. Okay, I write this out for you. You guys ever use this? I don't know if I've talked about it in this class or not. Desmos.com. It's a free calculator. Does much more than what your current calculators that you have handheld will do. I want you to start developing some familiarity with this over the next in those 6-7 weeks, because when you, on April 16th, you take the end of course exam, that's the calculator that the end of course exam integrates into their test. And if you develop an understanding of proficiency of it now, the calculator issues that people run into a lot of times in that test aren't going to be there for you. Okay? So when you go to Desmos.com, it should come up with a thing that says Explore Math with Desmos, and then it says Start Graphing. Just click Start Graphing, and that should take you into the calculator. Now, the left-hand side, that table on the left-hand side is actually the calculator. If we ever need to, I'll show you how that kind of integrates with the graph on the right. It's very similar. You guys watch me use GeoGebra a lot. It's very similar to that. But what is nice about this is like typing stuff on my TI-83 or 84 or those smaller red classroom calculators that I have. You have to understand the syntax of that calculator to kind of be proficient. What I mean by that, you have to understand the order of operation. You have to understand the process of typing like a fraction in and stuff like that. Where on Desmos, when I type something in, it's going to write it or type it like I would write it by hand. So that's a nice thing for you. I think it can be a problematic thing for us because I do like forcing students to kind of learn how this calculator works because you do need it for your ACT. But right now we're going to focus on using the Desmos calculator. All right, so that being said, I'm going to figure out what was it, 20 radical 2? So here's the thing, 20 square root of 2, it writes it out and it shows me what I am looking for as a decimal. Now it says round to the 10th place, so I'm going to look at that 2. Okay, that's the one I'm going to round, and the 8 tells me how to round it, right? So I'm going to round it 28.3. So 28.3. Okay. Now the second question is going to say, find the distance, or how much higher does the red brace land on the side of the house than what this brace right here lands on the side of the house. So them asking that, they're essentially saying, can you figure out what that length right there is? Okay. In words, that is how much higher the longer brace reaches than the shorter brace. Okay. So we need to know what that distance right there was, right? Well, if we go back to our 45, 45, 90 triangle, that was 10 radical 2, correct? We also need to know what this distance here is. Okay. Now we haven't dealt with finding that blue distance. Okay. But would you guys agree that in my 30, 60, 90 template, that's this distance right here? So I just need to take my n, which is 10 radical 2, and I need to multiply it by radical 3. So I get 10 radical 6. Is that okay there, everyone? So this distance here is 10 radical 6. We all right with that? Okay. So what would I do with that blue distance and this black distance here? What would I do with those two things to find this red one? I heard it. Somebody say subtract. Okay, that's what we want to do. So which one's... It's important, I think, to think about which one is bigger. 10 radical 6 is bigger. Okay. But if you neglect that, if you reverse the order here, you're either going to get the positive or negative version of the same number. If we talk about distance, you guys remember that distances, we're always looking about the absolute value, right? We're looking for the absolute value. So if you remember to put absolute value around, it doesn't then matter the order that you do this subtraction. But I know that that's going to kind of work out. Now here's the thing. You can type that in. That's a perfectly fine format. But you could also type this in. This means the same thing. Does that make sense? They both have a factor of 10 in them. So you might see, and we talked about this in the last class, when you guys get into The other classes that I teach, we use what's called WebAssign, different math programs that do your homework. And they might provide you, if you get a question wrong, and you use the format 10 radical 6 minus 10 radical 2, and that was wrong for the question. They might provide you feedback in regards to what the right answer is, but then the feedback might be 10 times the quantity radical 6 minus radical 2. Does that make sense? And I just want you to know that you're going to have to understand varying formats of the same number or the same quantity. So that's an exact value. Can I subtract radical 6 and radical 2? I can't. Okay. Now, in their decimal version, because they're just numbers, so radical 2 is like 1.4 something. Radical 6 is probably like, I don't know, 2.4 something. I could subtract those, right? But when they're in, exact form like this, the only time that I can combine those terms is when the number underneath, which we've been calling the radicand, that number there and that number there need to be the same so that I can add or subtract them. Okay? They're not, so right now I just leave it this way. Okay? So on Desmos, I'm going to type in 10 square root of 6. Is that what it was, right? Okay. Minus then 10 square root of 2. Okay. Now I'm going to type in, and we'll see what happens here. I'm going to type in 10.35 tells me to round that up to a what? What would I round 3 to if that's a 5? 4. Let's see what they tell me. 10.4. Just double check. And let's see here. Where's the button? Let's check answer. And this one says I'm right. Okay. Some of you are going to see that you typed in 10.4 and it says you're wrong. It should have said 10.3. Okay. So kind of talk about what's going on there with that. And we've got 2 triangles, right? And actually we've got 3 triangles, but if we look overall, that's 45 degrees, 75 degrees. So this angle up here is 105 degrees. So the overall triangle is not a right triangle. Whenever throughout the rest of the course, guys, you see these numbers, it should jump off the page at you that you want to deal with 30, 60, 90 triangles, special right triangles. So we've got 2 triangles. We've got triangle 1 here, triangle 2. You have to decide which triangle to start in. Okay? And you always want to make that distinction no matter what we're doing in regards to the triangle that you know the most information about. Okay? Now, in both of them, I know all 3 angles in both of them. But do I know any side lengths in this 30, 60, 90 triangle? No. Okay? But over here, I know one side length, right? So I know that it's going to make more sense just to, and in regards to being able to do stuff, I'm going to have to work in that triangle on the left. Okay? So I'm going to draw my template of 45, 45, 90. Okay? And this becomes n radical 2, right? Okay? If I draw them on top of one another, doesn't this become my n radical 2 side? Okay, so now I've got the equation n radical 2 is equal to 7 radical 2. So what does that tell me n is going to be in this case? N is 7. Okay, so if n is 7, that is the length of C, and it's the length of A, right? Okay with everybody? Now, knowing that then, does that allow me to transition into the second triangle? You now know a segment of that second triangle. So I'll draw that second triangle over here. So that's 30. That's 60. Okay. Now in the second triangle, now I'm going to use a different letter than N because we've already used that. I'm just going to use M. So this would be 2M. And this would be M radical 3, right? So now, with the 30, 60, 90 triangle, that there and that are going to overlap. So M is 7, So does it make this here 14? Okay. And now this distance here would be m root 3. So m was 7. So 7 root 3 would be that distance. A question that they are going to ask eventually is, what is that distance? And we use segment addition, right? We say up to right there. Okay, that segment right there between those two spots would be 7, correct? And then you're going to add to that, you're going to add to it this distance here, which was 7 root 3. Can I add those together? Can I combine that into one expression or one term? Because what's the radical that's going on with this that's kind of hidden or understood? It's a radical 1, right? You can only add radicals if those numbers underneath are the same, correct? They're not the same, okay? To make an argument about this, let's say that x was equal to radical 1 and y was equal to radical 3. If I did substitution with that, you would have 7x plus 7y, and we know that we can't make that like 14xy or anything like that with addition, right? So we just leave it as 7x plus 7y. So we leave this as 7 radical 1 plus 7 radical 3, or just 7 plus 7 radical 3. Okay? So we can't, by hand, write the exact answer any simpler than this, but if we were using our calculator, you know, we can't add those numbers together. We can take, 7 plus 7 radical 3. We can actually add them together and get that, right? But this number, it's kind of weird. 1, 2, 3, 4, 5. It's pretty rare that you see that. That decimal has no pattern to it. It's going to repeat forever. So once I cut that off, maybe I cut it off at what I've got highlighted. That's no longer 7 plus 7 radical 3. It's something a little bit less than that. Does that make sense, everybody? So we want to leave things as 7 plus 7 radical 3 in a lot of contexts, in a lot of problems. And that's really the question that people have a lot of times. Is like, when do I know when to leave it as 7 plus 7 radical 3, or when do I know to write it as a decimal?